All right, so you guys have seen linear equations, like things that fall perfectly into a line and are based on an equation. What we're going to be dealing with today are sets of data and how they can kind of fall into a linear pattern, which we call a scatter plot, and then we can make prediction equations that are based on linear functions. So first of all, there are three things that could happen if you're looking at a set of data. It could have a positive correlation, which would look something like this. You'd have a whole bunch of data points that when you plot them, whether they're close together or far apart or what, they basically end up kind of forming the pattern of a positive sloped line. So positive correlation means as one quantity increases, the other quantity increases, which makes it look like a positive slope. And then we have a negative correlation, which looks something like this. As one quantity is increasing, the other quantity is decreasing. And so your data is kind of set like that in a way that it kind of follows the pattern of a negative slope. So positive correlation, negative correlation, and then no correlation is if you were to plot your data and it's just kind of all over the place. It's really not fitting a pattern, doesn't kind of go up or go down, it's just spread around all over the place. So that's no correlation, meaning you couldn't find a line that would fit to the data. So this example, we've got some data right here. It's the mean selling price of new homes for 6 consecutive years. So first year, and then it goes all the way up through. So this is the mean price in thousands of dollars. So the first thing we're going to do is make a scatter plot. So when you guys are setting these up while you're working on the homework, set up axes like this. All right, and then you're going to label them. So this first quantity that goes on the top is always going to mark the x-axis. So our years are going to go here. And then our price is going to go here. Okay, and then you can label based on what you have with these points. So 0, 1, 2, 3, 4, 5. So we'll just mark 1, 2, 3, 4, and 5. So make sure those are evenly spaced apart, because if you're going to see a pattern, you want to make sure that you've got the correct spacing. And then up this axis right here, you don't want to start with 0 because our lowest value here is 154. So what you do is you put a little squiggle into the graph to show that you're not starting at 0. You're going to kind of condense the graph a little bit and start at a new point. So let's start at, we'll start at 150 and then we'll go up by 25. So this is 150,000, 175,000. 200,000, 225, 250, and 275. So again, make sure that these are equally spaced so that we can see the pattern if there is one. Okay, next we're going to plot these points. So the point 0 and then 154.5. So we start at 0 and then plot it. Do just your best estimate of where 154.5 would be, somewhere in between these two values. So definitely closer to 150, maybe around there. Okay, and then just keep doing that. Next, at 1, it's 166.4. So that would be right around halfway in between 150 and 175. 2 is 181.9, so that's above 175, probably a little closer to 175, you like that. 3 is at 207, so up just a little bit above 200. 4 is at 228.7, so that one's just a tiny little bit above the 225. So you can trace that over, so maybe right around there. And then 5 is at 273.5. So we have a little bit of a jump here, almost to the 275. Whoops, I wrote 273 because I saw that on the table. Sorry. All right, so it's not a perfect line. Like if you connected these dots, they wouldn't fall perfectly on a line, but they're pretty close. You can tell there's definitely a pattern. As the years go by, the price is increasing. So then a line of fit, you want to just kind of do your best and sketch in what you think a line of fit would look like. So I'm just going to grab a ruler. Okay, so to make the best line of fit, you want about half the data to be below it and half the data to be above it. So I'm going to draw maybe something like this. So you just do your best, estimate where you think it would fall. So something like that. Maybe you might want it to go a little lower, a little more slanted, whatever. Line of fit is something that you're sketching yourself. Describe the correlation. You want to put it into one of these three categories. This is definitely a positive correlation. It seems to have a positive slope as you're moving. All right, next, write a prediction equation. So you guys are going to be doing this in your homework. Write a prediction equation. You pick any 2 points. Now, I have some people that always pick the first and the last. That's fine. You could kind of go like this and go to the next 2. Pick any 2 points you want. I tend to go one from the beginning and one from the end. So you could get into that habit if you want to. So when you set up a slope, remember the slope is change in y over change in x. And so this is treated like your x value, and this is treated like your y value. So change in y, you do the second y value of 228.7 minus the first y value of 166.4. And remember, you don't have to use the values that I chose. And then over change in x, so this first x value is 4 minus the second x value, which is 1. So you can plug these values right into your calculator, because I know we're dealing with decimals here. So we are going to go 228.7 minus 166.4. I'm just plugging these in. You get 62.3. That's the change in price. And then 4 minus 1 is 3. That's the change in the number of years. So then divide those. 62.3 divided by 3. And I'm just going to round to the nearest tenth. You get about 20.8. Okay, so that's your slope. Then, remember, we learned how to make an equation by giving a point and a slope. So this is my slope. So remember, I'm trying to do this. Y equals mx plus b. So just pick a sample point. You can use one of the ones we use, like this one, for example. So remember, point slope form is an easy way to just plug in. So we start with this. So y minus, and the y value I'm using is 166.4, equals the slope, which I just found to be 20.8, and then x minus the x value I'm choosing, which is 1. Okay, so you're just going to simplify that up. So on this side, I'm going to distribute the 20.8. Okay, and then I'm going to add the 166.4 to both sides. Sorry, we're a little short on space here. So these cancel. So I get the y by itself. I have 20.8x, and then I'm going to plug this into my calculator. So a negative 20.8 plus 166.4. And that gives me a positive 145.6. So that's my prediction equation. Okay, next, predict the selling price of a new home for year 8. When it says to predict something, you're going to plug a value into your prediction equation right here. So we are predicting for x equals 8. And all we're going to do is take that x value and plug it into this equation right here. So y equals 20.8. We're plugging in 8 for x just into this equation, and then plus 145.6. So we can just plug this all in, and I will show you that. You can do 20.8 times 8 plus 145.6. You can just plug that in. And we get 312. So 312 is our prediction. Remember, it's in thousands, so we can write 312,000. All right, so our second one here, we've got the same instructions. I just kind of compacted them. So we have sales in music stores from 99 to 2008. So you can see this is definitely a negative correlation sort of situation, because of course as time goes on we're probably making fewer sales in music stores since everything's online. So first thing we're going to do is make a scatter plot. So we are going to set up years and then sales. So remember, your first variable is always listed on the x-axis, and then your second is on the y-axis. So we are going to do this, and then this little like squiggle, you're able to just cut out values. So these ones we've got years, and then this one will be sales. So this will kind of do the same little cut right here. So that way you don't have to start all the way from 0. So that's what this represents, is that you're not actually starting from 0. So the year, we would have 1999 would be our starting point. And then we can go from there. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, that would make this 2008. So we've got all of those years in between. And then this one, our lowest possible value is 30. So we're going to start this at 30. And then with all these, you just kind of pick an appropriate scale that you think is going to make the most sense based on the values that you have. So the highest that we want to get is up to 45. So maybe we could scale this by fives. So we'd say 30, 35, 40, 45. So just make sure that everything's spaced out and scaled appropriately. So now you're going to plot those points on there. So you've got 10 different points to plot. So 1999 is just about up at 45. So that would be right there. 2000 would be at 42.4. So if this is 40, this is 35. So this would be almost exactly halfway between 40 and 45. So that's for the year 2000. Be right about there. And then 42.5, pretty much the same for the next year. So like we're not really going to see a significant difference. So they might as well just go right next to each other. Then 36.8 for the next year. So this is, let's see. I'm just going to put those all on there. Okay. So then in 2002, we've got 36.8. Should be right around there. A lot of these are just approximating. 33.2. So that's right here, a little bit closer to 35 than 30. 32.5 would be just halfway in between. 39.4, we had a little bit of a spike there, so that would be almost up to the 40 again. 2006, 35.4, just above the 35. 2007 is 31.1, a little bit above the 30. And then 2008 is right exactly at 30, so right about there. Okay, so you start with the scatter plot. Your data looks like that. Definitely a negative correlation, but not quite as strong as the correlation that you had from the first one. So we've got a scatter plot. Line of fit, remember you're just kind of trying to make sure that you've got about half the data points below and about half of them above. So this one actually, if you go from end to end, just actually connecting those 2 points, that seems like it's going to actually be a pretty good line of fit, because it looks like these 4 will almost be like dead on the line. You'd have 2 above, and then that would leave these ones below. So that looks like it's actually going to be a pretty good approximation. So we'll do that. Okay. So that's your line of fit. Remember what you're looking for. If you can hit a bunch of them, of course, try to hit them, but then you want to split the difference, having as many points below as you would have above. So that's about what we did here. We've got, it looks like 4 of them that are, well, 3 of them that are like almost dead on the line. And then these ones are really close. We've got 2 above and 3 below. So that was probably about the best we could do there. Describe the correlation. So we've got, this is definitely a negative correlation. If you wanted to talk about the strength, I would say that's like a medium strength. It's not super strong because they're not really packed in, but I definitely wouldn't call it weak because they're not super spread apart. And write a prediction equation. Okay. So we're going to pick 2 points that seem like they're pretty close to being on the line. So this first point, and then you could either use the second to last point or the last point. So let's use this first point, and then let's just say the second to last point. So we set up our slope. Remember, that's the first thing that you do with your prediction equation. So the slope is m, and that is change in y over change in x. So change in y, your ending y value is 31.1. And then minus your starting y value is 44.5. And then over change in x. Sorry, I'm trying to get my calculator back. I put it away. And then over change in x, which would be the change in years. That is 2007 and then minus 1999. So we can plug this first part in and subtract. So when I do that, I get 31.1 minus 44.5. So that's negative 13. Oops, that's not showing up. There we go. Negative 13.4, and that should be negative because it was decreasing. So I get negative 13.4 over, and then subtract these years. And of course, that's an 8-year difference. So we've got that. So we divide negative 13.4 divided by 8, and we come up with negative 1.675. So that's your slope. That's approximately how much the sales are declining with each year that passes. So we have that. And then we're going to set up our equation. So let me just plug in these values. So the slope that we just found, that's going in for m. And then we have x minus, and then you just pick either one of these. Whichever one you prefer is fine. So this, I'll just use the 2007.
and then y minus 31.1. Remember, pick either point you want, but you can't mix and match. Like I can't take this x value and use this y value. That would mess you up. Okay, so distribute the negative 1.675. So then multiply these two. Distribute that negative 1.675 times the negative 2007. That gives us this value right here, 33,617.25. And then we would be adding this value over to the other side to get our actual equation. Okay, so let's see what we get here. This cancels. We get y equals, so this I have negative 1.675 times x, and then plus whatever I get when I add those two together. So I'm going to add 31 point, oops, that should be a 1, not a 7, sorry about that. So I get 33,648.35. So that is your prediction equation. I'm running out of space here, sorry. Then it says use the function to predict the percent of sales made in a music store in 2018. So that means that you're going to take the 2018 and plug that in for x. So that's what I'm going to do for the very last part. Lucky I've got a little bit of space down here. So replace the x with 2018. And then just like the last one, I can just plug this just right into my calculator and get a value. So we're going to have negative 1.675, whoops, times 2018, and then plus 33,648.35. So that gives us this very large value right here, 30,000 and then 218. Let's see, I think something went kind of weird here. Yes, it did. Okay, so I'm looking, sorry, at these calculations right here. When I took this value right here, my apologies, so I've got a mistake. When I took this value and distributed it right here, I had a decimal that I was off right here, so it threw me off by a decimal here. So this value should actually be 3361 and then 0.725. So the numbers were all right, but this decimal value is off by 1, so it threw the whole thing off by 1. So my apologies. And then the new value right here, let's see if we can make this make more sense. So 3361.725 and then plus 31.1. Okay, that makes a lot more sense. That value should actually be 3392.825. So change that. I apologize, I had just a weird little decimal thing going on there. Okay, so now plug that in. Let's try this one more time. We should get a value that makes more sense. So negative 1.675 times 2018, and then plus this new value, the 3392.825. Okay, so we end up with 12. And then the calculator says 0.675, but if you're looking at everything you have on the table, these only have one decimal place. So instead of 0.675, the 67 will round up to 0.7, and then that is in percent sales. So that would be our value there. Okay, so percent of sales that were made in music stores, so that makes sense. I mean, 2018 is next year. It would make sense that not a lot of music is being sold in the music store compared to everywhere else that you can get music now. All right, so those are our two examples for 2-5.